So the DSC WAVE stands for Wrangling, Analyzing, Visualizing Data. If you pop to the next slide, there should be one. Okay, great. So basically there are two parts to this project. It started with 8 schools in Western Massachusetts, 5 four-year institutions, 3 community colleges. One prong of the project is to make sure that undergraduates get experience doing real data science, working with messy data, doing collaborative work in a way that's different than group projects in classes, Scrum, GitHub, programming in R. And so in order to get projects for them, each school has a team each semester, and each team is partnered with a community organization. The community organizations have data and don't have people to work with it. So the students work directly with the community partner. Prong 2 is an effort to really, I would say, prototype how to do community college to four-year institution pathways for data science. And so a couple of people, Nick Horton and Ben Baumer, have been the primary people on the grant team, working closely with our community college partners, doing workshops for the community college faculty in developing intro data science courses at their institutions, and then working very closely with them and some of the four-year state universities to find the connections, the crosswalk between curricula and mapping that out. And there's a proposal into the Massachusetts Board of Ed, higher education, on how to make this pathway work across all of Massachusetts. So that's a quick summary. You can talk more at the poster.
Thank you. So next speaker is Imageomics from Tanya.
Hi all, this is the team. We have 3 representatives here. So Imageomics is one of the HDR institutes, a new frontier of biological informatics. Can we move that black thing that's been bugging me the whole time somewhere? Somewhere. Anyway, a new frontier of biological information powered by knowledge-guided machine learning. We have a large team across many institutions. 3 are here. Paula, maybe you already heard, one of the co-organizers of the previous panel, Chuck Stewart, his voice you've heard in the summary for the table, and we have many more. The whole point is to establish a whole new field of science, imageomics. Say it with me. So just like genomics before is going from sequences to biological information using quantitative approaches, imageomics is going back to looking at the world through images and extracting biological information, specifically biological traits from images using quantitative approaches. Can we, next slide? Yes, so the point is to take all kinds of image data that's available from many sources with additional text, geo, and molecular data. But all of this is actually sparse, imperfect, and heterogeneous data. Would love to talk to all of you who are dealing with sparse, imperfect, heterogeneous data and how to actually get useful information. We go the route of adding the biological structures to constrain the machine learning models. And biological structures, biology is the field that started with taxonomies and classification. Tons of structural data, tons of structural knowledge that can be added and really use the knowledge-guided machine learning approach. Would love to talk to those of you who are going in that direction and drive this towards explainable AI. So not only this is the species because it has these traits that we as humans may not even have been seeing. So next slide. This is the big structure. What I want to point out here is not only that we have connections to explainable AI, imperfect and sparse data, and knowledge-guided or domain-guided machine learning and structured machine learning approaches, but we also have a lot of connections to education. And I would love to connect to biodiversity data science core, conservation data science core, environmental sciences, as well as those who are looking at experiential learning. We're taking our students to Kenya, for example, and combining the data science education for domain scientists. Thank you. See our poster.
Hi, everybody. Can you hear me? Excellent. I'm Lenore Cowan. I'm at Tufts University, and I am, I guess, alphabetically the first representing one of the tripods institutes. Next slide, please. And the tripods institutes are organized around trying to get mathematicians, statisticians, computer scientists, and electrical engineers and information scientists, all of whom are trying to understand and make progress on the fundamental algorithms and techniques that drive data science, but they all have different vocabularies, talk across different things. So we wanted to do that in a interdisciplinary way. We organized around 3 different sort of special year type themes. The first was graph and tensors. And then we added spatial temporal data in our second year. And now we've added data guarantees, quality, transparency, privacy, fairness, and trust. And I especially want to emphasize that that includes a new focus on metadata that we're very, very interested in, that I can tell you some more about. And want to talk to some of the people here about. So next slide. I also wanted to talk about some of sort of the human resources pieces of this. The centerpiece of what we were doing was graduate training. We had these interdisciplinary teams where, in addition to somebody's primary faculty advisor, when they were a Tripods grad fellow, they were given 2 co-advisors in our 2 other departments. And incredible amounts of interdisciplinary publications have already come out of this. The other thing I wanted you to know, especially because the DISC people are here, is that the REU type program that we founded under the umbrella of Tripods has now been spun off and has independent funding and is recruiting next summer. And all your data science core alumni, it hasn't yet been posted for next summer in the ETAP NSF portal, but it will be by November. Please encourage your best undergraduates to apply to come to Tufts to work with us on data science next summer. And I put the students, they're facing backwards because we have the cool little Tufts jumbo elephant graph logo that I wanted to display. Finally, we have a project on teaching ethics in data science to undergraduates that we're going to be soliciting case studies. And any of you who would like to participate, there are more details, come see me when I come talk about my poster. Thank you.
Thanks. Next is Jennifer.
Hi, thank you. I'm Jennifer Drew from the University of Florida, and here with my partner.
Well, yeah, we're partners in crime, and I'm from Florida A&M University, Satya.
Hi, our project is called AI Across the Statewide Curriculum. It's a data science core project, and the original PI, I am not the original PI. The original PI is Brian Kolakowski, who's in a new position in government now. So I inherited the project, and as we said, it's a partnership between the 2 institutions, or not the only 2 institutions in Florida, but the 2 big institutions in Florida. And next slide. Our focus is primarily on building a diverse and skilled AI workforce. We're focusing on expanding the reach and the impact of the undergraduate AI curriculum, the applied AI curriculum. University of Florida, maybe you've heard, is a huge initiative all around AI education right now. And we have lots of different things going on, but our main 4 activities are to facilitate AI across the curriculum by enhancing, providing faculty with support to develop new courses, enhance the AI curriculum, expand course offerings. We're expanding participation and diversity of undergraduates in AI. We're offering diversity fellowships. We are offering research support for undergraduates, for teams or individuals to conduct AI research and address real world needs. And we are working to assess the project impacts. We're measuring changes in skills. We're establishing core competencies and best practices, and disseminating best practices for interinstitution partnerships and how to sustain the impact.
Yeah, we're doing 2 quick things. One is there is a major emphasis on diversity. That's where being an HBCU, Florida A&M, being a great partner with University of Florida, trying to bring that minorities into this. And the other thing that we are really doing is encouraging non-STEM participants to apply AI, like graphics and journalism or public health data, so we kind of encouraging that a lot and trying to bring faculty from those domains who typically don't apply AI in their domains. So that's one of the major core initiatives that we are focusing on in this project. Thank you.
Hi, I'm Jeff Arrington from the University at Buffalo. Our project is a collaborative project between the University at Buffalo, which is in the SUNY system, and the City College of New York, which is in the CUNY system. If you go to the next slide, please. So the primary goal of our project is to develop a digital badge program within the area of data science. The original motivation for this was to provide engineering majors a credential that they could integrate within their program of study. What we found, though, is that there's quite a bit of interest in terms of math majors, statistics majors, biology majors, other majors across the university in this program. The program itself consists of 4 elements. There are 2 courses, one introduction to data science, another communicating with data. The 3rd element is an internship, and the 4th element is a small capstone project. One of the unique features of the internship program is that students can either do an internship in sort of the conventional format, or they can do it through what we call a pop-up lab, where we solicit projects from organizations that perhaps are smaller, don't have the expertise in data science, don't have the ability to mentor students, and we bring them to campus and provide a means to actually deliver and work on those projects. In terms of accomplishments, we have developed and offered the courses multiple times. The micro-credential or digital badge program has been approved by the university, and we've welcomed 2 cohorts now through the program. So hope to see you at the poster.
Hi, my name is Patrick Flaherty. I'm in the Tripods Institute at UMass Amherst, and I'm in the Department of Mathematics and Statistics. Next slide, please. So I'll talk about a few accomplishments, and I just have one graph. One of the things that we did is we developed a summer pre-college data science course based on the Data 8 course at Berkeley. One of the things that we discovered with Tripods is our institute, and your institution maybe as well, like to jump on a successful bandwagon. And so when we got Tripods, we said, hey, would you like to be a part of this thing that's kind of going forward? And they said yes. And so we were able to get some funding from them to offer this data science course. And essentially they take no money from the course, and we get to plow all of that money back into this course. We were able to offer 4 scholarships, and it's taught by 4 tenure track faculty. And so you get these students kind of get that experience, and we've found through surveys that it really accelerates their kind of career in data science. The growth of the course has been pretty large even through COVID, and we're expanding it, and it's self-sustaining. We generate a lot of papers, and REU students, the last bullet point, one of the outcomes of generating a lot of papers is the people who work on those papers, the postdocs, end up getting jobs in other places and move on and kind of propagate the foundations that we've been developing. And so a couple of our postdocs are at our other universities now. We also have a lot of workshops that we recorded, and you're welcome to view those here. Those are well attended, and they'll be on our website for kind of in perpetuity of the website. So thank you, and I'm happy to talk about any of these things.
Hi, I'm Alex Franks. I'm one of the co-PIs on our grant, the Central Coast Data Science Partnership. Next slide, please. So our grant is a training grant connecting 3 main public higher education institutions in California. I'm at UC Santa Barbara. We've been working closely with Cal Poly, as well as Santa Barbara City College and Cal State San Bernardino. Next slide, please. So our grant supports a number of different activities, including the development of new courses at all levels of undergraduate curriculum, a summer research experience, as well as capstone projects. The bulk of our work has been focused on supporting data science fellows who are participants in our capstone project course. So our data science fellows receive a stipend upon acceptance into the program. And importantly, they serve as sort of the ambassadors of data science at our university. They participate in outreach activities, help with data science education, event planning, and infrastructure tasks. Our capstone sequence is a year-long sequence. They have a prep course in the fall and then 2 quarters working on a project. This past year, we had 14 projects. Half of them were partnered with local industries, and the other half were projects on local to Santa Barbara in a research lab. So I look forward to chatting with you more about it at my poster. Thanks.
Hi, everyone. My name is Arya Gangapathy. I'm from University of Maryland, Baltimore County. And this data science project is a collaborative grant consisting of 4 institutions, UMBC being the lead, and Towson University, Bowie State, and University of Baltimore being the other 3. There are 8 faculty members who are involved. And just from UMBC, we have had about 50 data science core cohorts in the last 3 years or so. Next slide, please. So this shows the curriculum map. On the top left, you see some of the fundamental principles and foundational principles of data science, all the way up to the application domains. Bottom left, you see that there are 3 pillars that we're using for this data science core. Training, and you see the training modules on the right. There are 8 training modules that have been developed by different faculty members. We are in the process of putting them on edX to make them publicly available, as well as we are thinking of creating a badge for data science for social good. And then at the top, you have the curriculum map, essentially mapping the training modules to the outputs, outcomes, and things like that. And then there's also a research component that all of our data science core students are actually participating under the leadership of faculty members and graduate students. And they're also actively participating in different community engagement. Next slide, please. So these are essentially 2 of the very commonly occurring challenges that we have found in data science, particularly when they're applied to smart cities or urban areas. At the top half are, one of the core techniques in data science is deep learnings. And as you know, deep learning models take a lot of data for training, and data collection is one of the bottlenecks. So the question is, can you really generate synthetic or semi-synthetic or quasi-synthetic data to train models that can be applied in real life domains? At the bottom, you're going to see some of the applications, some of the techniques or technological components that are needed to deploy these deep learning models on the edge, because that's also challenging in terms of the resource constraints and things like that. So these are some of the things that our students are actually learning and applying in real world. Thank you so much.
Hi, everyone. I am Jing Gao. I am Assistant Professor of Geospatial Data Science at the University of Delaware, and I present to you the Delaware and Mid-Atlantic Data Science Core. Next slide, please. So we are a partnership between the University of Delaware, Delaware State University, and Lincoln University. So the idea is to leverage resources at R1 University to improve the accessibility and inclusiveness of data science education in the region, including R2 universities and historically Black colleges and universities, which both Delaware State and Lincoln University are. Our activities, all of our activities are accessible to students at all 3 institutions, including a newly designed data science curriculum for both general introduction to data science and the specialized applications in 3 different disciplines, as well as master classes for advanced topics such as data ethics, communication, visualization, fun activities such as hackathon, mapathon, bootcamps in statistics and coding, and topped with internships with our research and industry partners. Happy to meet all of you. Hope we will talk.
Good afternoon. My name is Varun Gupta. I'm from U Chicago, and I'm a co-PI on the Tripod Phase 1 grant called IDEAL. IDEAL stands for the Institute for Data, Econometrics, Algorithms, and Learning. So as the name suggests, it's cross-disciplinary. Next slide, please. But it's also cross-institute. So there are 3 institutes involved in this grant, U Chicago, Northwestern, and Toyota Technological Institute. And one of the goals in writing this proposal was to encourage collaboration across these institutes and use the synergy of researchers across these institutes and help students also collaborate with people from across campuses. There are faculty involved from CS, Stats, Econ, OR, EE, and law as well. Research focus are on high dimensional data analysis, data science in strategic environments, and machine learning. Our modus operandi is that we are focused on special quarters. So we have had 6 special quarters, each quarter focused on a theme. We started with inference in networks, a deep learning quarter, one on high dimensional stats, and 2 sort of novel, interesting quarters have been on data science and law. So how data science can help practitioners in law, because these things are becoming common in court of law, how to use data. And the one that's going on right now is on data science and economics. So how do you think of data science? How do you put value on data, and how do you encourage that? We start each quarter with a kickoff meeting where we propose open problem, which kind of sets the stage for what might be interesting problems to tackle in the rest of the quarter, so that students can sort of sign up for these projects and encourage collaborations. I'll be happy to talk more during the poster session. Thank you.
Hi, I'm Mandy Herring from Baylor University, and I'm the PI of a data science course called Modernizing Water and Wastewater Treatment Through Data Science Education and Research, abbreviated MOWATER. So I take the blame for that acronym. Next slide, please. So this is joint with Baylor and Colorado School of Mines, and we had a former student who's now at West Point Military Academy. And we really have structured a lot of activities around water and wastewater treatment data. And why? Well, over $1 billion or $100 billion is spent every year in this country on water and wastewater treatment. And it's something that we take for granted, but there is a ton of data in this particular sector, with lots of potential for students to really do projects that are authentic and that can have some potential impact. So when we started this DSC, we looked at, we first were targeting sort of the lower level undergraduate students. So we built an introduction to data science course that's flipped and inquiry driven. Then we had a 5-week summer data science fellows program that a lot of the students from the class would matriculate into. And then we noticed that as we worked with a lot of stakeholder partners, utilities, consulting companies, national labs, that a lot of them wanted to learn some of these skills and tools. And so we started looking at people who are actually in environmental engineering. So we now have a MOWATER Pro short course for industry professionals, and they're actually paying us to take the course. We're not so, I guess, altruistic as some of you, is just putting all our stuff online. But what we found is that we're using those funds to continue to support our undergraduate students when the NSF funding expires. We're also now working on a 1-week data science workshop for graduate students in environmental engineering, and transitioning some of our students who are in data science into these advanced 8-week summer internships. So I'd be happy to talk with any of you about our lessons learned and also hear from you.
Hi, I'm presenting H3D3, standing for Accelerated Artificial Intelligence Algorithm for Data-Driven Discovery. So in this meeting, we have 3 representatives. Mark is, and then also the Phil. So 3 of us will be here. We would like to chat with you more about what H3D3, what we are working on. Our vision is establish a tightly coupled organization of domain scientists, computer scientists, engineers that unite 3 core components, technology that we are essential to achieve real-time artificial intelligence. We have 9 institutions and 17 senior personnel and 2 research scientists. But then the majority body of our institute are trainee. They are postdoc students, and we have 4 postdocs so far. what we want to do is to have clear scientific applications and try to take advantage of the advancement of AI algorithm development. Then we also need the computing hardware, which can take the AI to be accelerated in coprocessor or even put to the ASIC. So to make all this happen, we need this institute to consolidate everyone's effort together. If we can look at the 2 dimensions, one is the latency, what's the time required to make every AI inference calculation, and also the throughput, and that is the for every second how much data we can push through. If you look at the challenge we have, we cover quite large of the scientific area, all require low latency and high throughput, including the hybrid physics, neuroscience, and also multi-messenger astrophysics. Compared to what the Google Cloud is, and our challenge is automatically larger than Google. In order to make all this happen, and we have to cooperate with our industry partner, try to investigate the cutting edge device. So we have a poster trying to describe more detail about the 3 science domain we have. And in addition, in particular, Mark is leading the community engagement effort. We are looking forward to establish a broader cooperation with all the HDR community. Thank you.
Thank you so much. Good afternoon, everyone. I'm here representing IHARP, Institute for Harnessing Data and Model Revolution, along with Jianwu Wang and Sudeep Chakrabarty, our newest recruit from NASA JPL. We're trying to bring all the best in the team as well. There's overall over 50 participants in this institute across 9 institutions, across several industry participants as well. And the key question that I'd like to throw out there is, if you look at the sea level rise discussion, that by 2100, there's an estimate that there'll be a 0.6 meter rise in the sea level. But if you look at all the estimates, there's a range from 20 centimeters to 2 meters. That's a big range for any of our scientists, right? There's a lot of uncertainty in there. And IHARP is really focusing on looking at the polar data and models to reduce that uncertainty. So if I look into the next slide, please. The polar systems are really complex. There's ice sheets, which is just the Arctic and Antarctic, let's say Greenland in the Arctic region. There's ice in the ocean. There's lots of subsystems in the Arctic and Antarctic as well. If you just look at Greenland, central Greenland, North Greenland behaves very differently from the coastal Greenland. And just looking at that type of granularity and connection is the kind of complexity we are dealing with. And if you look at the bottom right portion of the screen, it shows all of those subsystems and interactions. And one quick example I'll give you is, let's say a crack starts forming in the northern Greenland region. It's very different from a crack forming closer to a glacier where there could be a massive runoff into the river or into the ocean and leading to the sea level rise. How do we find those smaller subsystems and where changes are happening and connect the dots to have causal inference to show that the sea level will rise with such certain percentage? So Jianwu is actually focusing a lot on the causality stuff as well. And that's where our vision comes in. How do we use the data and models to reduce that uncertainty? If you can go to the next one. I just wanted to throw in a couple of examples on the next slide to show you the types of scientific pursuits that we're looking at. There's tons of remote sensing data as early as the 70s and even before. We have photographic data as well. How do we mine that data? How do we find those substructures on the ice surface? But also looking at below the ice surface. So if you look at radar imagery that looks at layers of ice, if you trace annotate the data, you can actually trace the ice back to the ice age. So the trick is really fine-grained computer vision, which really defeats many of the algorithms that are out there for larger object detection. But doing fine-grained detection and then even connecting those pictures or stitching them together is one big challenge. The other piece is regional influence, as I mentioned, the northern Greenland versus coastal Greenland. How do we account for the spatial and temporal heterogeneity? Scalability becomes a big part again, looking at how do we harness all of this together. Causal inference, I'm trying to rush through a lot of those, but I want to also mention the education and outreach. The biggest thing that we found is working with the number of domain experts on polar science data. It's not one or two, it's many, many different subsystems that are being studied. So how do we bring different people into the mix? We regularly do Talk Tuesdays every month. We'll send out those invites to folks here. We already did a iHarpathon, which was really fun working with the domain scientists. So those are the types of interesting things we're also looking at. I think I did 2 minutes, right? Thank you. Thank you so much.
Hello, I'm Mi Kyung. I'm a statistician who's currently at Department of Mathematics at University of Houston. And we can just move on to the next slide. So all the information about the university's partners for this program is in my poster. But in short, our goal is to train workforce for the data science in energy industry in Houston. I feel like Houston is like an area with a lot of potential, a lot of sort of unexplored people and talent who can go into the energy industry and who can contribute to the data science for energy transition. So our team is a multi-institutional team of 5 universities in the area. University of Houston is a leading institution, but we are partnered with the University of Houston Downtown, Victoria, Clear Lake, and Sam Houston State. So I still remember the time that when I was just Googling them and contacting them and asking them if they were interested in joining. Now we are really a well-established team that we are working together since October 2021. And so our program has kind of 4 activities, starting with the summer boot camp for 5 weeks. And we are opening our program to undergraduates and the master's level students who have 0 background in data science. And so we train them over the 5 weeks in the summer. And then in the fall semester, they take more advanced courses that are relevant to data science and energy related principle. And then in the spring, they're going to do a team project, and all the data are going to be provided by our industry partner, who range from a large oil and gas company, and also going down to more like a consulting company or smaller startup companies on energy related problems. And so then we'll close the program with a summer internship after they all train through summer camp and more advanced courses and the research project. They will now go to the industry to do the summer internship. So we just started last year. We just finished our first summer camp for the cohort 1. We had 32 students who participated. We started with hybrid online and in person, and then there were COVID cases as we were going through the summer camp. So we had to switch back to 100% online. And so that was a little unfortunate, but still students had fun. They learned a lot, and we are looking forward to the future activities. Thank you.
I am Kristen Cuter. I am at the St. Mary's College. I'm presenting yet another acronym for you all today. Our DSC project is ITREDS, which stands for, and I have to cheat, Interdisciplinary Traineeship for Socially Responsible and Engaged Data Scientists. I'm also joined by my colleague at the University of Notre Dame, Tom, here in the front. Our fearless leader, our PI, Nitesh Chawla, could not attend. I think he had another engagement. But so our project is a collaboration between our 2 institutions that focuses on providing traineeship for undergraduate students across many disciplines. Maybe go to the next slide. Built on this T-shaped scholar, where we're providing kind of a breadth across different professional and super skills, but then depth within a given expertise, data science, computer science, statistics, math. But the vision is to provide interdisciplinary experiential learning so that the students can actually see and create impact of their work for society, working together with stakeholders, and focusing on projects that are data centered and human centered. Next slide. So it's a 2-year program. The students apply in their sophomore year and then start coursework in the junior year. It's a cohort-based model. There are 2 courses that the students take in their junior year together. The first one is a design thinking course. And then the second is a data ethics course. And then the rest of the curriculum depends on what area the student is coming from. So St. Mary's students are taking an intro data science course at St. Mary's, other data science electives, and then breakdown for the other sources of students. So we have Notre Dame computer science students and our minor in data science students. Those are our 3 main audiences. And then in the senior year, the students are put together on interdisciplinary teams to work on their capstone project. So we're pulling St. Mary's students together with Notre Dame students from the various audiences, and trying to pair them with different stakeholders, whether it's a community organization or a faculty project at one of the institutions, for them to apply the skills that they're learning in their courses. And then they present on their capstone project at the end of the year. And yeah, I think that's all I have to say.
Yeah, I think this will be the last presentation for lunch.
Hello, I'm Cameron.
And I'm Everton.
And we're here representing DIMAX Data Inspire at Rutgers. Our institute brings together researchers from mathematics, computer science, and statistics in order to address fundamental principles of data science. We're particularly interested in understanding the operation of intelligent machines and their safe deployment, while at the same time we aim to reduce our dependence on large and accurately labeled data sets.
Can you change the slides? Okay, so we're going to present 2 posters that is related to one of those topics, that is understanding data-driven dynamical systems, and where we are interested in making robust predictions about long-term dynamics based on sparse samples, and crucially quantify the error related to these predictions. So one major current application, it is in robotics. So we analyze data-driven robotic control, and we integrate surrogate model and mathematical tools for safe deployment of the robot and synthesize the effective hybrid controls. And thanks for your attention.